Hey guys, welcome back to my channel. Hope you are doing extremely well, and this is a very own mass code at the side. So welcome back to the Heaps playlist, and we're going to see a basic question today only. Check if an array represents a heap or not. For this question, for this playlist, please make sure to watch the intro. If you do not know anything about heap, we have just discussed about briefly like what is a heap, how does it work, how do we represent a heap, right? Okay, so in the previous video we configured that heap is nothing but a binary tree, and to be precise it is a complete binary tree structure, right, following a property whether like anyone from the below. First property can be parent greater than children or equals to also. Second property is parent less than equals to children, right? And this property, the first property heap, is known as max heap because the root element is the maximum element, and the second property heap is known as minimum heap, min heap, because the root element is the minimum element. These are some basic points of the heap that you must know before proceeding with the playlist. Now we also discussed towards the end that the heap is represented not by a tree, it is simply represented by an array. The reason for that is because we know that a heap is a complete binary tree, so we can just write the level or a traversal of that binary tree into a form of array, and whenever we require we can make a binary tree out of it because we just know, right, what are the children, what are the parent, right, etc. Now the question is exactly that. The question is molded according to that. The question says, do you have an input as an array? The input is 90, 15, 10, 7, 12, 2. You have to tell me whether this is a max heap or not. You can do the same for the min heap as well. First, we will discuss about the max heap, then towards the min heap. Only one question is sufficient for both of them. Now, how you will tell them whether it is a max heap or not? So, if you remember from the video before, like the first video, you see that the given array is 90, 15, 10, 7, 12, 2. So, if I try to make the heap out of it, if I try to represent the heap out of it, how will I do it? So I know the first element is going to be my root. Why? Because it is just the level of traversal. 90 followed by 15 followed by 10. Now you can say that 10 can also, it could have gone something like this: 90, 15, 10, 7, right? But no. Why? Because it has been mentioned that heap is a complete binary tree, right? So it will go only like this. So 90, 15, 10 followed by 7. So 7 will be its left, then 12, then 2, right? So you just have to fill the level order reversal of a complete binary tree. This is the heap we are representing from this array, and you have to tell me whether this is a valid max heap or not. So let us check whether it is a valid max heap or not. 90 is greater than 15 as well as 10. 15 is greater than 7 as well as 12. 10 is greater than 2. That means it is a valid max heap, and we have to return true for it. So let us try to draw the heap for it. So 9 followed by 15, 10, 7, 12, 11. Now if I check 9 not greater than 15, not greater than 10, that means it is not a max heap. It might be a min heap. We didn't check for it. Let us check for it as well. 9, 15, 10. Okay, min heap property is getting followed. But for 15, 7 and 12 are both lesser, so min heap property is not being followed. It is neither a min heap not a max heap, right? Okay. Now, how to do it without converting into the tree, right? How to do it with the form of array only without converting into the tree. Now, if I try to see 90, 15, 10, 7, 12, 2, right? This is my tree. The array looks something like this: 90, 15, 10, 7, 12, 2. We discussed in the previous video as well. It is just a reminder. Now, if I try to mark the indexes, so 0, 1, 2, 3, 4, 5. Now let us try to compare the array with the tree, right? 90. 90 is at index 0, 15 at index 1, 10 at index 2, index 3, index 4, index 5. That means 0 is the parent of 1, 2. 1 is the parent of 3, 4. And 2 is the parent of 5. 6 index is not present. If 6 would have been present, then 2 would have been the parent of 6 as well. 6 would have been mentioned here only, right? So if I try to deduce a relation, can I say that if the node is I, then its children are gonna be present at the indexes 2 into I plus 1, comma 2 into I plus 2. Can I say something like that? 2 into I plus 1, that is 2 into 0 plus 1, that is 1. 2 into 0 plus 2, that is 2. 2 into 1 plus 1, 3. 2 into 1 plus 2, 4. 2 into 2 plus 1, 5. 2 into 2 plus 2, 6. It is not present here. Otherwise, it would have been mentioned here only, right? So, parent, I, children, 2y plus 1, 2y plus 2. And to be precise, it is the left child, it is the right child, right? And from to determine whether it is a heap or not, we just wanted the relation between its parent and its children, right? Can we do that with the array only? Yes, because we just wanted the parent and children identification, right? We did that. Now what can we do? We know that for it to be a max heap, parent should be greater than node, like not only children node, right? So what will I say? I will just run a loop. So for I going from up till 5 last index, that is n minus 1, we can say. What do? I will say 0 should be compared with 15 and 10. That means left child is 2y plus 1 and right child is 2y plus 2. Now what will I do? I will say if my left is less than n, that is it is inbound in the array, and my array of left. Now, if I want that it should be less than the node, but if it is greater than the node, array of I, in that case return minus 1, that is return false, that it is not a max heap. It is not a max heap. Similarly, for right one, so if right is less than n and array of left is greater than, not array of left, it is array of right greater than I, in that case also return false. But what if this whole loop works without returning anything? That means it is a max heap, so return true, right? So what did we do? We just checked the parent with its left child and its right child present at index 2y plus 1 and 2y plus 2, right? Now this is the case for max heap. For the min heap, you just have to do something like this. The sign will change, right? Because you just wanted the greater children in the below, but they are actually lesser children, right? This is simple, right? What is the time complexity we are using? O of n time complexity. Why? Because we are just checking through the array O of n traversal, right? Okay, so let us move to the code now. So here is the coding section, but before starting with the code, it's my sincere request for you to please subscribe to the channel because it really motivates me, right? The simple steps, right? So for int I going from 0 I up till n I plus plus, int left is gonna be 2 star I plus 1 and right is gonna be 2 star I plus 2. If my left is less than n, that is it is inbound, and ARR of left somehow gets greater than ARR right, in that case it is not a max heap, so return false. Similarly, if right is inbounds and ARR of right is greater than, not ARR of right, it is ARR of I, right? ARR of I, similarly return false, otherwise return true. Let us try to compile and run it. Hope it will work fine. It is running absolutely fine for the sample test case. Let us try it for the hidden test cases as well. In the meantime, do consider subscribing to the channel because it takes a lot of effort, right? Okay, so thank you for watching. Hope you liked it and meet in the next video. Till then, stay tuned and keep coding. Thank you.